Hi, this is Annette and Austin's lab on the rotation of the sun. So, a little background information on sunspots. In 1613, Galileo used the telescope to observe sunspots. He quickly recognized that the sunspots moved as the sun rotated. Sunspots grow and shrink in size, and they also last a few weeks before fading out. The sun is too bright and the sunspots are too small to be seen with the naked eye. So that's why we use a telescope. We use sunspots to figure out how fast the sun spins on its axis. Sunspots appear in cycles, and we're just not sure why. They're large fire streams, and they're shooting out from the sun. When sunspots release their energy, they shoot beams of negative charge electrons into space, some of which escape into the Earth's atmosphere. These electrons cause electrical effects, such as the northern lights, and they also increase in the ozone. Okay, so now we're going to jump into the lab. So what you're going to first do is File, Login. Under student number 1, you're going to write the name instructor. Press OK. Have you finished logging in? Yes. Now the password that you're going to enter is going to be in all caps. And type in CLEA. Then press OK. Now the point of this is we want to make sure that the centroding is on. And so mine is on, has a little check mark by it. If it's not, just click on it and then press OK. Yes, yes. Okay, so there's the lab, the period of rotation of the sun. You're going to go to File, Run, and then you're going to come up with this cool screen. So then you're going to say File, Image Database, Image Directory, and then Load. This then brings you to a page. And this is the pictures that we want to click on, the A list. So double click on those, and then they're going to come up in your image database directory. What you're going to do now is double click on about 7 images. 1, 2, 3, 4, 5, 6, 7. Okay, so this is showing you pictures of the sun in different times. You can see the darker spots are your sunspots. Okay, so this is the images that you've loaded. So you're going to click on your first image, and then now you're going to pick a sunspot to measure. You're going to want to pick one for the first part of this lab close to the equator. And pick something visible that you can track throughout. So you can kind of click and see, which one do I still see? So we're going to go ahead and go with this sunspot. So you click on it, and then under spot ID, you're going to put the number A, or just any letter to help you know. It's going to be consistent throughout. So you're going to press Record, Finish. Okay, so then you're going to double click on your second image. Find the same sunspot, but it's going to be in a little bit of a different spot because it's moving. So you're going to double click or just click once. Spot A, same one because it's the same sunspot. Just going to exit out of this. Same sunspot, press Record, Finish. Okay, you're going to continue and do this. So click on this one, press A, Record, Finish. And again, this is the same sunspot. You're going to do it again for this. Record A, Record, Finish. Click on your next picture. Same sunspot that we're tracking. A, Record, Finish. Next picture. We're almost done. Hang on with me. One more. A, record, finish. So hopefully you have memorized what to do there because we did it about 7 times. So since we have all of our sunspots recorded, we're going to watch them move across the sun. So what you're going to do is go to your picture and press animation on. And then there you go. It kind of blinks the images for us so we can see where the sunspot is and how it's moving. So once you see that it is moving, you're going to press animation off. And then now we're going to actually look at the information that we've recorded. So you're going to go to File, Measurement Data, View and Edit. And so this is your information. And basically this is your spot ID, the one that we've labeled A, the date, the universal time, the longitude, and the latitude. So what you're going to want to do next is print this off. So press list, and then print, and then go from there.
Alright, so now we're going to plot this data onto a grid. So go Analysis, Plot, and so here's your grid. Our data is already loaded, but what you would normally do is go File, Dataset, Load. We're going to just do the longitude values for now. Later on you'll do latitude. So click longitude. Here's your data. Double click on it, and it would load for you. And normally this green line is just called like the line of best fit. So you can scroll it down, make sure it lines up with your data, and once you think you got it lined up, go to Fine and just adjust it a little bit more. Always make sure that these numbers are green, so that means you're going through all of them. So once everything's lined up, go to File, Record Results, and so here it shows it's the spot A, that's the sunspot. This T0, this means, so say we go to, alright, so when we look back at our sun, we have our point of origin right about here, and we'll say the prime meridian is running straight through the middle. This T0 means that's the time, like when the sunspot crosses that line. So
also, this right here means the number of degrees our sunspot moves across the sky per day.
Alright, so once you have that, just hit OK and OK.
Okay, and so then you're going to do one more thing. You're going to go to File, and then you print your window. And then the next part of our lab will show you.
Yes, so just print it and you're good for now. So now you're going to take the data you got from the chart we just did and enter it into your word chart. So you're going to take this slope, which is down here. So we have 13.1. And we're going to go to that, we call this T0 over in this section. And let's see, how did we get that? We went File. Oh, it's right there. Just kidding, it's right in front of you. Okay. Open up Word and type in 2, 4, 5. Okay, so that's your T0. That was when the sunspot crosses the prime meridian. And now the synodic rotation rate, that's how long it takes the sunspot to rotate all around. So you're going to take S, so your slope, you're going to take 360 divided by your slope, which was right over here, so 13.1, and that's good for that one. Now the sidereal rotation rate is kind of a confusing concept. So because the Earth is spinning around the sun so fast, this synodic rotation rate isn't really accurate enough. It's almost like trying to measure your friend doing or going one time around a merry-go-round while you're walking around it at the same time. So it's really hard to try to calculate that. So this formula will, what's the word? It'll calculate it without the Earth's rotation. So you're going to take S, which is whatever number you get for this. So that's going to be your S. You're going to multiply that by 365.25, and whatever answer you get for whatever's in these parentheses, you're going to divide that by taking S again, but adding 365.25 to it. And divide those two answers, and you will get the sidereal rotation rate. Okay, what we're going to do now is copy this chart over into Excel, and we'll start making formulas so we don't have to do all this crappy math. Just make it easier for us. Alright, so go ahead and open up Excel and select cell A1, and we're just going to start typing in all this stuff. So first, write the name of the lab, which is rotation of the sun. And okay, we'll make that a little bit bigger. So highlight all of this and go 20. Just click on the cell, and it'll fit everything in there. Now let's see, we'll do sunspot. And we're just going to go straight across this top line. We'll call this one just synodic, so it fits in there. And we'll call this one sidereal. We'll go down, we'll skip a spot, we'll call this sunspot E, sunspot P, oops. And we'll do that one, sunspot P. Now underneath slope, we'll write down its degrees per day, just so we can remember that. Degrees per day. And under intercept, we'll just write JDN. And if you remember, that was when the sunspot crosses kind of that midpoint, the vertical axis of the sun. And we'll type in this formula for the synodic down here. So you just click up here in this box just to type. Do S equals 360 divided by slope. And for sidereal, we'll go ahead and type in this formula as well, just to remind ourselves. So parentheses S, no, that's not a parentheses. No, there we go. Parentheses S. Do times. Where'd it go? There it is. 365.25. End parentheses divided by parentheses S plus 365.25. And end parentheses. Nope, didn't get that last one, did it? No, it didn't. Alright, there we go. So now we can type in, so you can look for E, we got 13.1. You're going to have different numbers, but this is just what Annette and I got. And we're going to start making formulas, so we can just type in numbers and the computer will calculate it itself. So we're going to go to the synodic. Oh, we're right there. Cool. And so to start a formula, you always type in this box and start off with equals. So that knows, okay, he wants to do a formula. So yeah. Now we're going to type in, let's see, our formula is 360 divided by slope. So we'll do 360, oh, why does that keep coming up? 360 divided by, and our slope is right over here, so we're going to click D4, nope, that's B4, so it knows, okay, take 360 divided by whatever's in this cell. So that's all good. We're going to hit enter, and it gives us the number without doing all that, or we don't have to do any of the math. And now to bring that, so here's our formula. To bring that down for the sunspot P, you click on this little tiny box, drag it down, and now your formula is good for this box. And all this, the div divided by 0, all that junk just means that you haven't typed in anything. So say you type in a number, it'll calculate it for you. So for now you can just leave that blank until you go back. And now for the side reel. This one's a little bit more complicated, but it's still doing the exact same thing. We're going to go to, so click on the cell, type in equals to start off the formula, and let's see. So we need slope, which is, which slope? So we're going to take this number, no, I'm just kidding, we're going to take this number, the synodic, so click on that so it knows D4, and we want to multiply that by 365.25, so hit asterisk 365.25, and we're going to want to put that in parentheses so it knows which order to do everything in. Alright, now we will divide that by, do another parentheses, S, so slope plus 365.25. So divide by, click D4 again, and do plus 365.25. And end parentheses. Nope, that's a 0. End parentheses. So now you can tell, or so it calculated that for us, and you can tell that these two numbers are slightly different. And because remember, this was just how many times it takes for it to go around the sun. This was, say you're walking around that merry-go-round trying to calculate how many times or how long it takes for your friend to go around. So this number right here is just taking out the Earth's spin in the equation. And once again, we're going to copy the formula down here. So drag it down, and you're good to go for that. So now, once again, if we were to type in, we'll say 14.6, hit enter, it's going to calculate both for us, saving you all this not fun math. So that wraps up how to do the Excel spreadsheet. Hopefully more on your way to becoming professional astronomers. So hope this video helps out, and yeah, let us know if you need any help.